Okay, carrying straight on from the last video, we have a couple more questions to answer. So the first question we need to answer is, what about acids? So a lot of these reactions that we're going to be looking at involve acids, and what happens to those? Well, when we deal with acids, we'll always be dealing with them in aqueous solution, which we know means dissolved in water. So we normally will consider three common acids, which are HCl, hydrochloric acid, HNO3, nitric acid, and H2SO4, sulfuric acid. Okay, you might want to add the names of those above them. That's hydrochloric, this is nitric, and this is sulfuric acid. So, all of these acids, when they are dissolved in aqueous solution, they will produce H plus ions. Okay, that is what an acid does. So I get my H plus. Now, if this is H plus over here, this is going to be Cl minus. All right, exactly the same way as we did for ionic compounds. We have an H plus and a Cl minus, and it's the same for all acids. So we have H plus here, and then this here is going to be our nitrate ion. So that's going to be NO3 minus. Now here, we're going to make H plus, but there's a 2 after the H, so I can produce 2 H plus ions, and then I get my sulfate ion, SO4 2 minus. So whenever you see H2SO4 aqueous, you know that it will produce 2 H plus and SO4 2 minus. So again, we see that this 2 here becomes a 2 in front of the H plus because I've got 2 of those H pluses. All right. So even though I've got 2 hydrogens in my sulfuric acid molecule, when I dissolve it in water and it separates into ions, I get 2 H plus ions. So I have a big 2 in front now. Okay, so pause the video there, copy those down into your book. And the final question we need to answer is, what about covalent compounds? All right, so in these equations, we might see things like H2 gas or Cl2 gas, or even H2O liquid. Now, these are all covalently bonded compounds. Okay, you can see that there's only non-metals in here. Okay, there's no metal, and none of these are acids, like we've previously seen. So if, let's just suppose if I was to separate this into H plus, well, that would mean that because this is a neutral molecule and I've got H plus here, I would have to separate this into H minus. And we know that that doesn't happen. Okay? Likewise, up here, if we separated it into, well, chlorine is in group 7, so it would form a Cl minus ion. If that happened, well, this is neutral and this is negative, so this would need to be Cl positive. And we know that chlorine doesn't do that, doesn't lose an electron to form a positive ion, so that can't happen. Okay, so covalent compounds do not separate into ions. Okay, what do separate into ions are acids in aqueous solution and ionic compounds which are molten or also in aqueous solution. Right, so now that we know what happens when our ions can separate, we can now start to look at some of these ionic equations. So, solid sodium metal is exactly that. It's just solid sodium metal. Now I have an acid in aqueous solution. So that's going to be H plus Cl minus gives me Na plus. This is also an aqueous solution. Plus Cl minus. Plus, now this is a gas, and it's a covalent compound, so it's going to be H2 gas. Now, what have I forgotten to do? First thing you should always do is balance the equation. So I've got 2 hydrogens here, which means I need 2 HCl there. If I've got 2 chlorines here, I need to have 2 chlorines there. And now I've got 2 sodiums, so I need a sodium there. Now, 2 sodiums, 2 sodiums. 2 hydrochloric acids is going to produce 2 H plus ions. 2 hydrochloric acids is going to produce 2 chloride ions. Sodium chloride, I'm going to get 2 of those and 2 of those. So now all we need to do is decide which are the spectator ions. We can see that on both sides of the equation I've got chloride. Now I write out my ionic equation, which is 2Na solid plus 2H plus AQ gives me 2Na plus AQ plus H2 gas. Okay, right, your go. So I've written out one here as a word equation, and I want you to have a go at that. So it's lithium metal plus nitric acid gives me lithium nitrate, which dissolves in water, plus hydrogen gas. So pause the video and have a go at that. Okay, so we've got lithium plus our acid, which is going to be aqueous solution, gives us Li, well, lithium is in group 1, so it's going to be Li plus. Nitric acid forms a nitrate, which is NO3 minus, so it's going to be NO3. So it's going to be 1-to-1 ratio. That's going to be an aqueous solution plus H2 gas. Now, is it balanced? No, it's not. So I've got 2 hydrogens here, so I need to have 2 hydrogens here. Now I've got 2 NO3s here, so I need to have a 2 there to make 2 NO3s, and because I've now got 2 lithiums, I need 2 lithiums there. So all I need to do now is separate it into the ions where possible. Lithium just stays as lithium, so that's 2Lis plus. Now this will separate into ions. Each nitric acid will produce 1 hydrogen plus ion, but I've got 2 of them, so it's 2H plus again 2NO3 minus. And the same here. Each lithium nitrate will give me 1 lithium ion, but I've got 2 of those. It's going to be 2Li plus 2NO3 minus. And my hydrogen is covalent and it's a gas, so it doesn't separate. So I get H2 gas. Now I need to decide which are my spectator ions. I can see that I've got nitrates on both sides, so I get rid of those. And now I can write out 2Lis plus 2H plus AQ will give me 2Li plus AQ plus H2 gas. Excellent. Okay, so I've got down here 2 more that you need to have a go at. Okay, see you in the next video.